Human Immunity by Hayley Sharpley. So what is an infection? An infection is an invasion of the body by microorganisms such as bacteria, viruses and parasites, which are not normally found in the body. Not all infections can cause symptoms, which makes them difficult to be identified. Infections can stay local to the area but can also spread to specific organs, and they can multiply and take over the entire body. Infections can cause fevers and other health issues depending on where they occur. And there's 4 main types of infections, which is bacteria, viruses, fungi and parasites. Okay, so there's 4 types of methods to transmission. So the first one would be direct contact. So that's person to person, such as touching, kissing, coughing and sneezing. And also animal to person, which is where a scratch or a bite from an infected animal can infect the person. And indirect contact is where an infected person touches a surface and another person touches that surface, such as a door handle. And also insect bites, and an example of this would be malaria, which is passed on through a mosquito bite, and also food contamination. And this is where humans consume food that has got germs on it, and this happens by not washing or cooking food properly. Okay, so the first line of defence would be the barriers to an infection. So this is a defence of physical and chemical barriers which are always ready to defend the body. The skin acts as barriers between invaders, and the body which forms a waterproof mechanical barrier, and it's made up of 3 different layers. And these layers are called dermis, epidermis and subcutaneous. The epidermis makes melanin, which helps protect the skin against sunburnt and obviously the UV rays. Okay, so look into this a little bit more deeper. We'll look into mucous membranes, and this lines the surface of the eyes, the ears, the nose and sinuses, and the mouth, and many more as well. Thin and soft tissues that lines cavities of the body, which are contagious with the skin. It coats the secretions and fights microorganisms and forms the effective defence against infections. And this lubricates the body to help you blink, protect stomach against the lining of stomach acid, and it neutralises threats by removing or trapping the substances. Okay, so an example of this would be the urinary tract. So the bladder is protected by the urethra found in males and females. It's thin and begins at the lower opening of the bladder and extends through the pelvis to the outside of the body. The females is generally shorter, which makes women more prone to having water infections, and the urethra flushes out urine regularly to stop harmful bacteria causing an infection. Okay, so the second line of defence is inflammation. So this happens when invaders have penetrated the first line of defence and that's completely broken down. This will release chemicals including histamines, which trigger the inflammation response, which will attack foreign invaders. This triggers an increase in blood flow and pushes the blood flow down to the infected area a lot faster. White blood cells are attracted, which will send them to the injury, and symptoms will include swelling, pain, pus, redness and a high temperature. And here you can see this is when histamines are released by mast cells leading to inflammation. So you can see here it breaking through the skin. Okay, so moving on to macrophages. So these are specialised large white blood cells involved in the detection of phagocytosis and destruction of bacteria. There are many types of macrophages, and the name is given to where it's found in the body. And they are presented antigens to T cells and initiate inflammation by molecules that active other cells. Okay, so if we look into phagocytosis in a bit more details, this is where certain living cells ingest other cells or particles and dispose of them out of the body. The process where monocytes can turn into macrophages and target cells which help eliminate bacteria. An ingested microbe is engulfed, called phagosome, which is a vessel which forms around the microbe by the cell membrane. This is then fused with lysosome, which contains digestive enzymes and disintegrates the contents of the phagosome. Okay, so the third line of defence is pathogens. So a pathogen is an effective agent that causes the immune response, and these are bacterial, viruses, and also protozoans and fungi. And there are 6 different examples of pathogens, 4 living and 4 non-living. So you can see here, these are the cellular, so these are the 4 living, and the 2 non-living, which are acellular. So moving on to antigens, so this is the part of the pathogen that alerts the body when it is under attack, and it causes the immune system to respond. This can be any type of molecule. This can be proteins on a virus. For example, this would be flu, that helps the virus enter the cell. Pathogen is needed for the protein to infect the host, ready to battle with the body's ability to recognise the antigens and stop the infection. Okay, so what is acquired immunity? So acquired immunity is a learnt response from the body's immune system to determine the most effective way to attack antigens, which then develops a memory for that antigen. When a person is exposed to the natural environment, the immune system encounters antigens. And there is 2, these are known as actively and passively. So actively intentionally exposes to a foreign antigen in a vaccine, and passively introduces preformed antibodies into the body, which allows protective immune activity. Okay, so if we look at different types of the roles of different types of immune cells, so leukocytes are also known as white blood cells, and these are a vital element for the immune system to help fight infection. These are made up of 5 different types of leukocytes, which are all produced within the bone marrow. So here you can see the 5 different types of leukocytes, which is neutrophils, lymphocytes, monocytes, eosinophils, and basophils, which, like I said, make up the white blood cells. They are found in the lymph system and tissue throughout the body, and they are always ready to attack. Okay, so we just look at those in a bit more detail. We'll look at filler cells first, which defend against bacteria and parasites. These release histamines and herpamines. They do not need to know where the invasion is happening before they're ready to spring into action. And the second one we'll look at is neutrophils. And neutrophils target bacteria and fungus, and they multiply and respond fast, which gives a high white blood count. Okay, so moving on to immunoglobulins and antibodies. So antibodies are proteins that are bound to antigens. The role of the antibodies include targeting infection, recruits immune cells, neutralization of toxins, removes antigens, and stimulates cells that can eat foreign substances. Immunoglobulins are made up of 4 different chains, which are 2 lighter and 2 heavier, which are arranged in a Y shape, as you can see here. Here's the Y shape, and as you can see here, they have the light chain, and here the heavier chain. So there's 5 different types of immunoglobulins. So if we just see the 5 different types here, you have IgG, IgE, IgD, IgM, and IgA. So they're all different and have different roles. So if we look into those a bit more detail, we'll look at immunoglobulin A, which is IgA. This is the second most abundant, which plays the role in the cellular defense of the moist mucous surface, and the lack of this can cause infections in the mucous surface. So if we look at M, which is the next one, which is this one here, so this is a different shape. This is the largest and is the first one to be synthesized in response to an antigen or microbe, and this accounting for 5% of all immunoglobulins presented within the blood. So if we look at E, which is this one here, and this has concentrated 1,000 times more lower than IgG. Immunoglobulin G The isoform accounts to 70-75% of all human immunoglobulins found in the body. And if we finally look at immunoglobulin D, which is IgD, this is uncommon, and its true function of the immune system is still to be discovered, although its function to an antigen receptor on the surface of the B cells. Okay, so moving on to self and non-self recognition. So the immune system, to keep healthy, can distinguish between the body's cells and foreign cells. The immune system achieves this by mechanics of antigens. A unique characteristic of antigens allows the immune system to distinguish between itself and non-self, meaning only the non-self would be attacked. There are two crucial factors which allow the immune system to determine between self and non-self, are all major histocompatibility complex 1 and 2, which is MCH1 and MCH2. So if we look at MCH1, this acts as an early warning to the immune system to recognise foreign cells. They express on the surface of the nucleated cells, and if it contains a foreign protein, it will degrade the protein into fragments. So MCH class 2, these have a similar role, but only presented in certain cells of the immune system. These will present an antigen fragments on the surface of an immune cell ready for targeting. Okay, so moving on to organ transplants and how they can be rejected. So a healthy organ can be transplanted from one person to another person. This occurs when damaged or dead tissues are found within the body. A match must be as close as possible to allow the immune system to accept the organ and to stop it from recognising as a non-self antigen, which could lead the body to completely rejecting the organ. So there's 3 different types of organ transplant rejections. So that would be hyperacute, which occurs within minutes when the antigens are unmatched, and also acute, which will occur within a week to 3 months, and also chronic, which will take place over many years. Okay, so looking at immune system disorders. So an autoimmune disease is where the immune system mistakenly attacks its own body. It sees foreign invaders and it prepares to attack them. This can happen anywhere in the body and can be triggered by bacteria, drugs, chemical and environmental irritants, and then they can be very difficult to diagnose, but often the symptoms are very similar. Okay, so if we just look at some of these diseases in a little bit more details, there is a vast amount of different types of autoimmune diseases, but I'm just going to talk about MS and lupus. So MS is multiple sclerosis, which is autoimmune disease which causes damage into the coating of the nerve. MS affects the brain and the spinal cords, and the symptoms include visual problems, arm and leg movements, and it's a lifelong condition that causes severe disability, and it affects over 100,000 people within the UK. And lupus affects over 5 million people worldwide. The white blood cells attack the body, and it can take up to 7 years for this disease to be diagnosed. It's very difficult to diagnose this one. There is no cure, but symptoms can be managed. It's a long-term condition which causes joint pain, extreme fatigue, and skin rashes, and some of the triggers could be sunlight and stress. Okay, so acquired immunity. This is achieved by creating antibodies to a disease or an illness where the body is exposed to a pathogen. There are 2 types of immunity exist, which is active and passive. So active includes natural and artificial induced immunity. This is where someone is exposed to a pathogen which triggers the immune systems to produce antibodies, resisting the build-up through immunisation, so that's through the vaccines. Passive is antibodies that are given from one person to another. So this could be a mother giving her baby some milk, so obviously all her antigens would be passed through to the baby, and also the placenta as well, so the baby can get all the goodness and antibodies through the placenta. Okay, so looking at vaccines in a bit more detail. So a vaccine is where it's exposed to the immune system to a weakened or harmless pathogen to generate white blood cells to produce antibodies to improve immunity against certain pathogens. This can contain a live pathogen, which are made up of harmless, dead pathogens and toxins produced by pathogens. Although vaccines contain weakened and harmless versions of a pathogen, there is still a chance that a person can have side effects as well. So you will need to look into that a little bit more detail to see exactly what kind of side effects that they can cause. If a person is later infected with the pathogen, white blood cells are able to reproduce very quickly and rapidly, and they will destroy it. And this is known as immunologic memory. So immunologic memory relies on the immune system being triggered by the past antigen, in the past by an antigen. The primary response is where a pathogen is encountered for the first time, and it takes time for the antigen to be identified by the B lymphocytes, and the appropriate antibody is to be produced. So the secondary response is the same pathogen is encountered for the second time, and the memory cells recognise this pathogen and they produce a higher amount of antibodies. So there is many benefits of having vaccines, even though there is some side effects, like I said earlier, but there is some great benefits. So these give protection against diseases. They have successively eradicated various diseases over decades, and this has saved costs on the healthcare in total. So before vaccines, childhood deaths were more common from diseases such as measles, polio and whooping cough. All vaccines can protect life, so especially for the older generation. So it's crucial for the older generation to have their flu jab because it could very easily end their life. So if we look at measles, in 1963, measles vaccine was rolled out. By the late 1970s, a goal was set to completely eliminate the disease, and this was very successful over the years. There have been successful all over the world to completely eradicate measles, although there has been a sharp spike between 2001 and 2015, and this is due to a decline in childhood vaccines. So there is a movement called the anti-vaxxers, which is a lot of people that kind of feel that vaccines are not safe, and they will decline the vaccines for the children. So unfortunately, by people doing this, this has seen a sharp spike in these eradicated diseases coming back. Okay, so finally, we're just going to move on to herd immunity and the vaccine programs. So herd immunity is where a large proportion of the population is vaccinated against a disease. This helps protect those who are not vaccinated. So there is some people that can't be vaccinated due to health issues. So it still protects them and stops the widespread of contagious diseases from breaking out again. So protective isolation is crucial. So this is where a person has been infected by the disease. They must self-isolate to stop the spread of the disease to other people. So until they're out of the dangerous period, they should self-isolate. The NHS offer a wide range of vaccines to protect newborn babies, to the elderly, to middle-aged people. So there is a vaccine out there for everyone against these diseases. And without vaccines, the population would see a real harmful rise in diseases. And this would basically, without people being vaccinated, this could really, really could help really could harm the population worldwide. So, but like I said, there is an increased amount of people that are declining vaccines because there is concerns with safety of them. But like I said, with every vaccine does come some side effects, so it is crucial that you look into that before you consider it. Okay, so that's it. Thank you.